My name's Aurelie Portas, PhD student. I'm here to talk about the characterization of marine eukaryotic biofilms in the context of renewable marine energies. The aim is to compare different extraction methods and multiple genetic markers to maximize the identification of the diversity of status. It is a challenge for the marine renewable energy sector because they localize in dynamic environments and affected by colonization whose little is known about the long-term effect. We immersed artificial surfaces at different sites along the French coast and we tested two hypotheses. Firstly, we extracted DNA using 4 methods in order to obtain the highest marine eukaryotic diversity. In this part, only the V7 region of the ATSR DNA gene was used as primers. Secondly, we use only the power micelle kit and amplify 5 regions of the ATSR DNA gene and the mitochondrial CO1 with the same aim to get the highest marine eukaryotic diversity. We also have 3 other samples from another French Mediterranean and Atlantic site to assess the seed effects versus the primer effect. On the first graph, you can see the Cairo index showing the highest richness was reached for kit method, whereas grading methods. Considering beta diversity, we clearly see that extraction methods influence community structure. However, this Venn diagram shows that there are more than 70% of shared genera. This highlights that beta diversity differences come only from the relative abundance of the shared genera. In the second part, we look how primer influence the diversity. At first sight, we can see on the NMDS that the major clustering factor was a site. However, when we focus on tailored samples, the second NMDS demonstrated community structure dissimilarities according to primers. CO1 generated the most dissimilar communities, displaying in addition the lowest richness. Affiliation showed that CO1 only targeted microorganisms. If we look closer to the specific genera identified for each marker, both the V4 primers failed identifying chromobiont, especially diatom and brown algae. In conclusion, kit method for DNA extraction collected the higher diversity in comparison to grading methods, despite of a high percent of shared genus. Remarkably, we also observed some variability in the structure of communities according to the primer used as their target-specific taxa. In future studies, it will be wise to combine 2 sets of primers targeting the CO1 and the 3 regions of the ATSR DNA gene to capture the diversity of marine eukaryotic in biofilm community. Thanks for your attention.